All right, let's go. Guys, we have 140 slides. Are you ready? I have a lot of memes, so it's okay. All right. We are going to learn, many of you already know that, but how to avoid ourselves to be shot in the foot. And we love to be shot in the foot, but I think we want to stop this. Quickly, Stefan, CTO, co-founder of Conductor. Our office is actually just up there. So if you want to talk Kafka, just come here. We are just. Go back to the first step. Yeah. I want to take photo. This one. Who never shot himself in the foot with Kafka? Nobody, because everyone did. Very quickly, Conductor. We help organizations to scale their data streaming in their company. A big part of it is free, so don't hesitate to go to the website. And we do very fancy things. I'm going to talk about it after. So let's start talking about Kafka. I'm just going to talk about Kafka right now, just pure Kafka, and all the challenges that comes with Kafka. We all did many mistakes. A lot of us, we know, did a lot of mistakes, but well, it's time to stop a bit. We'll talk about what is happening today in the ecosystem and how. Basically, what is the future, let's say, of the Kafka protocol, I would say, not even Kafka. Simple issues. Okay, meme time. Topic names, stupid topic names. We all saw these kind of things that you have no idea what's happening. It's common. Partitions, the famous, golden question. How many partitions? There is no answer almost, except power answers. This one, replica 1. It may look like a good idea. Don't play with this one. Replication vector. So this one, some companies go to 5 from my knowledge. I don't know if someone saw more than 5, but it's already very specific, I would say. Kafka is not an FTP. I think a lot of banks, maybe in banks, we send PDFs, I love to troll banks.
80 megabytes.
80 megabytes in Kafka, so it's not the best idea in the world, probably. Retention. You want to send more and more data into Kafka these days. So Kafka is growing. Someone needs to take care of it somehow. This thing, ACLs, even today in big organizations, there is no ACL. So ACL is the security layer, basically, on Kafka. So everyone has access to everything. It's still something today. No monitoring Kafka, because monitoring Kafka is complicated. We are all aware of this. No alerting. If you don't have monitoring, anyway, you don't have alerting. So it's solved. Anyway, this is just a very small sample of the pains that many of us know about Kafka. We've been there. Everything is linked actually to your maturity level. This is similar a bit to the Confluent one, but hey, you start somewhere with a POC with Kafka, then you go to production because hey, your POC works, so let's put it in production. Then you have more projects connecting them to your new data because Kafka is very cool. And then in your business, it's just everywhere. And you look behind and you say, oh, Kafka is really critical and all my applications are critical right now. And if something fails somewhere, the business may be down because shit happened, especially with Kafka. And so we are going to basically navigate up to the end. One thing, some of you might say, yeah, but I have a CI/CD because we are serious in the business. So we have a CI/CD to protect ourselves from the bad behaviors in Kafka, like number of partitions, like topic names. Very nice. It will protect you up to a certain point, because if you have a CI/CD, it's to protect your Kafka resources. So the topic names and the things that you create in Kafka. Your clients, your application, your producers and your consumers, basically, into Kafka. Today, you cannot check what they are doing with Kafka because they are directly connected to Kafka, your clients and your Kafka brokers, basically. How can you control that they are not doing stupid things in your infrastructure? For instance, let's say I have a Kafka producer or a Kafka consumer. How can you protect yourself from default settings like this one. No linger remes, like it's often, the default is 0, I think. No compression, not a good thing. The batch size by default it's 200, I think. Basically, nothing is very configured for your use case. You use the default, you are going to do something wrong. Your application are not going to be very powerful. Outdated library. I have Python, Rust, Java, very old Java. How do you protect yourself from the old configuration, from the old library? Let's say you have an old Spring Boot somewhere in your company. It is not updated. It is not using the latest configuration from Kafka. It is using the old ones, and the old ones are not very good. How do you know today what is happening in your ecosystem? This one, yeah, I'm sending records to Kafka. Everything looks good. You are missing one parameter right now. You are missing the second parameter to actually get the feedback loop from, is the data really produced well? Did it work or did it not work? How do you know that you don't have an application not checking that the records are actually produced and that something is not wrong somewhere? You just don't know. Convention, sorry for the US citizen here. How do you protect yourself from, the group ID, group instance ID, client ID, the headers? In an organization, you probably want to have some clear, namings in everything you send to Kafka. CI/CD is not going to protect you from this because clients talk to Kafka directly, not via your CI/CD. This one, I love it. I did it a few years ago. Consumer overcommit. Basically, you read a piece of data from Kafka, a record, and you commit. You do something and you commit, and then you read and you commit, and you read and you commit, and you commit for every single record. I saw this in production. It works, but Kafka, it's not supposed to work like a queue. You do not commit for every single record. You commit by batch. Sometimes when you have a beautiful code, these kind of things are hidden deep into the code. Nobody sees them, but actually it happens, and you commit every single record, and it is going to break your Kafka. All right. X0, yeah, it's amazing. One company, from my understanding, knows do that. It's Criteo. I don't know if other company is doing this, but you really have to have a really strong use case, like metrics, for instance, where it's not critical at all, and you just send your thing without checking. But why would you send X0? There is generally no reason to use this kind of properties, and nothing will go faster. Nothing at all in Kafka will go faster. It's just that I don't look. I send crap. I don't look. So generally, it's not useful. This one, don't do this in production. And you can do this. Right now, you code a Java application, you put 0. By default, it's 1. You put 0, you can see, just do that on your Mac, for instance. You will see your Kafka CPU going from your Mac CPU to go to 30%. Doing nothing. You just set that in a consumer, and your CPU is going to scale like stupid. So do that on Confluent Cloud or MSK and see what's going to happen. How do you protect yourself from this? As a platform engineer, how are you sure that some developer is not reading internet and does that? No idea. Idempotency, this one I love it. You consume data. You are supposed to be idempotent. Basically, you don't want to process twice the same record. How do you know? How do you know basically today? You have no idea. And a big part of, so this talk is poison pills. So poison pills is you read data, you cannot process this data. So as a consumer, what is going to happen? What can you do? This is a big part of Kafka because as soon as an application send data to Kafka, and if they send like what we call a poison pill, so bad data, you can break the whole downstream ecosystem in your organization, because according to how the application downstream, the consumers are set up, are coded, were built, some of them might fail, some of them might do nothing, some of them might have ordering issue tomorrow after. You have no idea what's going to happen. How can you protect yourself basically to not send poison pill into Kafka directly? We are going just to navigate 5 use cases of what is a poison pill really. Some of them it will ring a bell. Some of them you will see, shit, how do I protect myself from this? Well, I will present them directly. Okay, let's put a context. You have a producer, a topic, and an application, consumer processing. Okay, very simple thing with Kafka. You send data, 3 fields, everything is all right, okay? Then you have a new application joining. So a new consumer basically joins the game, an audit system. So you have 2 applications, 1 topic, and 1 producer. Let's play some game. Audit can come into the game, read from the start, okay, everything is all right. I need JSON data, you are happy. Something happened, someone write a Kafka console producer, for instance, he published data just to test something, and he sends something stupid, he's just testing, and he misconfigures everything. Hello. According to who built this, they can die, or they cannot die. And this guy is like, sorry, I did a mistake. But you did a mistake. If you were in production, you are not going just to be sorry. You may be fired or something. So don't play too much with that. But it's not his fault. He's a new developer. He just joined the company. How do you protect yourself and how do you protect this person to not committing a mistake, actually? One simple strategy is the one that we all love. You catch an exception, whatever you do. You don't look. You say, oh, I put a message in my log, log4j thing, and I move on. Who is looking at its logs in its application? Nobody in the world is looking at the logs. So basically, you don't look. You log and forget. But you log and forget. What if it was not just this mistake, but what if you are processing like some kind of order ID? So the ordering in Kafka is very important. What happens if you process order update before order created? You have no idea what's going to happen. If you fail to read the order created event and you read order updated, you have no idea basically because of the ordering issue. And the log won't save you basically. The nice one, when you need tooling, like Conductor, you have your application reading, Kafka. They try to read this. Obviously, boom, they fail. What is happening when they fail? Basically, you are probably on Kubernetes or something. They are going to crash because, hey, I did my job well. I fail fast. You fail fast, you restart here. So they read again from there because the last commit was here. They see this message, they fail. Okay, infinite loop. It's not going to help you. It's just going to create more logs that nobody is watching anyway. Your data log is you are going to consume your Datadog and you will be happy. And meanwhile, the business is just gone because you are looping on a stupid record. And nothing is happening. Someone needs to do something. A human basically needs to do something here. They will detect this loop somehow because they have monitoring or alerting, hopefully. And they will need to say, okay, the guy building the audit system will say, oh, fuck, this record is crap. I need to jump. Basically, my application needs to jump to the next one to be able to resume basically how I consume Kafka. The same team here will do the same. Shit, my application is not working. What do I have to do? Okay, I have to jump to the next one. This is an ideal world. I have just one record failing. What if I have 2? What if I have 3? How do the teams here, how do they know that they need to, how many records they need to jump forward? And what if I have another stupid record just after? So I fix something, shit happened again. How do I do? Basically, you need a support team to use some kind of tooling to jump the records. Think in a real organization, you don't have just 2 applications reading a topic. If you have like 50 applications, the 50 consumer group basically in Kafka needs to jump forward to basically ignore the record. Probably not scalable. Yeah, stop and heal, whatever. Another one, who has dead letter queues with Kafka today? Yeah. Are you monitoring them? Are you watching them? Are they important? Yeah? Yeah? More or less? Okay. So how do we deal with GLQs with Kafka? Basically, multiple patterns we're going to explore. So as an application, if I read, bad data, the GLQ helps me actually to say, I read bad data. I don't want just to put a log, in my application logs because I have thousands of logs per minute. I will put clearly an event in a dedicated topic, which is a topic with like a suffix or whatever, for my application, DLQ. This way, every single time I have a record that I cannot read, my application cannot read, it can actually send this data, this piece of data, to the DLQ. It's not that simple. We are going to explore why actually DLQ is a pattern that we have to master a bit more. Let's say, I hope you see everything, but just a general idea. This is the original topic with the stupid records, and these are the two DLQs, okay? So now these guys processing an audit are reading the bad data, the hello world from the payment topic. So what's going to happen? You can build something on your consumer side. So on your application, your Spring Boot, your Python, your whatever, you build a code to say, okay, catch exception, I catch something I cannot read, producer send to my DLQ. The processing team owns their topic, the audit team owns their own DLQ topics as well. What do? They just produce to their own DLQ. Very easy, and at least now you have a source of truth of what happened. So it happened during the weekend. You come back on Monday morning. Shit, I have some records in my DLQ. So now you can investigate and you can do something about the business logic and find actually who did that in the end. And you move on and nothing happens. A better pattern is to do it on the producer side. So instead of sending, bogus data into the topic, you probably want to protect yourself from sending this poor data in the first place. So the producer needs to basically add some code before sending its own data to Kafka to have like some checks, some business checks to say, I won't send my data. I did some formula, I did my business logic, but somehow the data inside is wrong. It cannot fix itself, but it can detect that, I don't know, I have a quantity -1. Why am I sending quantity -1? I should not do that. Okay, I send to my own DLQ. So this application, the producer could have its own DLQ. This is not easy to do because if you are writing your producer application, you probably wrote an algorithm which is not failing somehow, but this is what we call a bug. How do you catch a bug? So you need someone to actually add some kind of checks to be sure that even if you did your algorithm well, what if there was a bug in your algorithm? How do you protect basically the whole ecosystem in Kafka to not ingest your data? So this is basically the DLQ on the producer side. The two person who answer, I have a DLQ. What type of DLQ are you using, like on the producer side, on the consumer side? Consumer? Consumer as well? Why on the consumer side and why not on the producer?
You need to ask the devs.
Same answer?
Yeah. Plus we have as well like a backup, like a mechanism to self-heal. I don't want maybe spoil. Maybe
it's okay.
But yeah, we use Kafka, we use SQS as well.
Okay.
So as our DLQ, we go to SQS and we can better manage that. Yeah.
All right. Okay. Interesting. So there is a small trick with the DLQ. Is linked to the retries. So basically, when you read data, let's say I'm doing stream processing with Kafka Stream. Sorry, I'm writing that. I contact an external API. Let's say it fails because banking systems API always fails for some reason. Should I send this data to my DLQ or not? Obviously not. From our perspective right now, if it is failing, I know it won't fail maybe in 1 second, in 2 seconds. I will retry. So I will basically build a retrying logic to be sure that somehow it should work. Eventually it should work. I cannot wait too much because if I'm not processing this one, I'm not processing all the new records that are happening are coming into my topic. So I will retry. And if I retry like 5 times, I need to send this data to a DLQ because I'm probably stuck. Maybe there is something happening in this data that the banking system API, it just cannot process it for some reason because of mistake in the values and something. And so this is where you actually have to manage two kind of strategy is, can I retry when I cannot process a record? What is the real reason behind the scene? Is this something that I cannot retry because it's stupid, it's quantity -1? Or is this something, another side effect somewhere that eventually will go through and I should retry? Okay, so this is the kind of thing, the GLQ is not just a magical pattern, catch exception, send to GLQ, no. Catch exception, retry if it makes sense, and then you catch again if it really cannot go through, and then you send to the GLQ. Otherwise, you are going to have a massive GLQ for no reason. What makes a good GLQ? So it's very nice to have topics, with all the records that failed somehow. But, okay, one thing. Let's say you have a lot of records now in your DLQ. It's Monday morning, I come to my job, I see 10 records in my DLQ. And then what? What do I do? If you just see the record, the original record, you don't have any context, you don't know why, so you cannot actually fix the thing. You don't know what to do. You cannot just send back the data into the original topic because it will crash again. So someone has to have some context to know actually what to do, what to fix, a human probably. This is a Kafka quick, record. Basically, you have a partition, an offset, a timestamp. You have some headers, just a map of bytes, and you have the real payload with the byte representing the value, more or less. To make a GLQ, when you send the data to a GLQ, you really need to keep the context of the original message, because what's going to happen when you are going to produce your data to your DLQ? You are going to have a new partition offset timestamp because of Kafka producer. You are going to forget the existing one. So one thing to not forget, I don't know if you guys you do it, but you have to basically copy the existing metadata to new fields to be sure that when someone is going to look, they will know the origin, where actually the mistake happened. And you need the why. When something is failing, for instance, here it's amount negative. If you say, I have a business rule, my amount must not be negative, I have to say it because a human will come, will look at that. Where does it come from? Why did it fail? And then, amount negative, shit, I have something. He will fix the amount and send it back basically to Kafka to really process the thing. So if you don't do that, your DLQ is probably useless because you are not going to help the support person who is going to fix the thing. And the funny thing, I saw DLQs, nobody was watching. Everybody was waiting for the retention period, 2 weeks. Oh, you don't look, 2 weeks later, the DLQ is empty. Good job. But actually, it's why do you have a DLQ in the first place? It's useless. Do you have alerting on your DLQ? John, do you have alerting on your DLQ?
Some of them do, yeah.
Some of them? I love them. Yeah, so 3 things to always have: monitoring, the context, and the alerting, obviously. Typically, a DLQ, you are not in early production. You already, hit some words. If you have a GLQ, it's because you start to be really critical, meaning that if I have a mistake in this application, my data may be sensitive and I really need to reprocess them because someone is going to be really pissed off if I don't reprocess basically this data. So you are a bit more mature. Let's talk about the schema registry. Right now we are just talking about Kafka, raw bytes. Schema registry brings a lot of very new, funny issues. Schema registry is just a new moving part, in your ecosystem. And now each of your records has a small, schema ID. Basically here it's 1. So it's the blue thing, it's still the same, it's 1. Basically, a schema is just the shape of your data. Why it's important? Because we are going to talk about schema evolutions, because you are going to add fields, you are going to change the structure of your data. And so you need basically schema evolutions. And schema evolutions, they bring a lot of new topics, let's say. Okay, I have a schema 1, I want to add a field. Very, very basic. This is really the go-to things that we do. You know that your application was developed against a specific version in your Java, in your Python, something. And you will probably do like some upgrades to your application to say, oh, I want to read the version 2 now, because the old one, the first one, it does not have like the currency field. I want to read the currency because I have some new business thing to do. Easy peasy, this is a nominal use case, nothing fancy here. Now your PO comes and obviously wants to mess up. You say, okay, now I need to change entirely my thing. So this is not a string anymore, this is a structure. So it's definitely not compatible from one version to another one. What can happen if you messed up a bit with your schema registry and remove some rules? My application, processing and audit here, they know how to read the schema 2, so this schema. They will try to read this. Obviously, they will try to deserialize the payload. They say, boom, kaboom. And then we enter into the previous game of how do I deal with my mistake? A DLQ, I log and forget, whatever the hell you have to do. But right now you have a poison pill. So this is a poison pill. It's like someone did not take care of managing the compatibility. Kaboom, explosion. The solution of today in this world is to version your topics. So every single time you have a breaking change in your schema, you have to create a new topic with its own, lineage of compatible schemas. So in this case, I have a new topic, payment V2, V3, V2 actually is the topic, and the first schema will actually be 3. So these guys, processing V2 and audit V2, they don't know yet how to read that. They will keep reading the old format of the data. This way they won't break. But then you have a choice here. The payment application has a choice to be made. Do they keep to publish the same data in the old format and into the new format? Or do they stop publishing the data in the old topic and they only take care of the new format? It will depend if you want your processing, the old application, to basically go to a dead end because no more records are going to produce. But if you don't notify them, you are going to probably to have a big issue if you care about real time because the data will be there and they will be stuck basically at the end here. So it can be tricky. And if you want to dual publish, well, you have to probably do a transaction, a Kafka transaction. You have to handle your code to basically handle both formats in the original application. So on the publisher side, producer side, it's a bit, I don't want to do that. I don't want to manage basically multiple versions of my data because the burden is on me right now to manage all of this. So it can be very, very tricky, but sometimes you just have no choice. Because if you think this application, it's a legacy system. It is just reading this. There is no more team associated to this project. It's running well, there is no team. You cannot ask them to migrate because there is nobody here. It happens in organization. I don't know, there is a project, it's running. I don't know who takes care, and there is no one actually taking care of it. And so you have this issue of, I need to dual publish my thing. And if you think, oh, no, I need another version, V3, V4, and you start to having a pile of topics that you have to maintain to still producing data just because of very old consumers. Very tricky, very tricky. Yeah. This use case, so let's say the schema ID brings a lot of new funny things. As an application, as a consumer, I expect to have raw data, for instance, so a schema ID. What happens when you send JSON, pure JSON, in my topic? So it's the same shape, okay, it's just JSON, but it is not serialized via the schema registry. When can this happen? Let's say I read this data, in my Kafka console consumer. I see the JSON because I don't see Avro. Avro is a binary. I see this. I say, oh, it's cool. No, I will use Kafka console producer to send it back. But I will copy paste basically my JSON in my terminal. I will copy paste it in my Kafka console producer, and I will send JSON. Because Avro is actually something hidden behind the scene, and so I have the same data, but this is not Avro. This is JSON. These guys, they don't know how to read JSON. They just read Avro. So kaboom! It happened by mistake, and it happened really when you don't expect it, but still it happens. This one is also a funny one. I read my data. I have the version 1 here. I have the same shape of data. This one is 8. So the schema ID is 8. Somehow, this application, I'm in production, they will read the schema ID. They will say, okay, it's 8. And so you know what happens when you find the schema ID. You hit your schema registry. And it can happen that the schema registry will say, I don't know what is 8. I have never seen this schema. How can it happen? It happens because you have like something, a cross-environment thing. You may have your pre-prod here. And this guy, misconfiguration, it happened. Instead of pointing of producing to pre-prod, this guy is producing to the Kafka in prod, but is connected to the schema registry of pre-prod. Basically, you are moving the 8 from the pre-prod to 8 of prod. These guys, boom. So it does not mean that because you have a schema ID that it exists. Or even worse, you can remove a schema registry. You can remove subject schemas in the schema registry. If I remove 8, maybe was there in the past. Someone removed it because he thought that it was a good thing. You know, he wants to clean up its schema because he has to pay for the schemas. Boom, you just remove how to deserialize a piece of data. And so right now, these guys, they don't know what is the shape of the data. Kaboom. It happens, deletion of schema in prod by mistake, it happens. And so now we move a bit more. Let's say we don't have this kind of mistakes, of the schema ID thing. But in Avro or protobuf, you'd say this field is an integer. Cool. Does that make sense? Makes no sense at all. How do you protect basically yourself from semantically wrong data? This is totally wrong. But Avro does not have any, you cannot declare what are the constraints on the field. Like in Postgres. Postgres, you had, constraint age minus greater than 0 and less than 120 something. You don't have this in Kafka. There is no such thing. Because Kafka just knows about bytes. It does not know about any shape of data. So what's going to happen? Again, this is always the same story. The shape of the data is good. Amount is still a number. It's -10. From should have been an IBAN. It's something stupid. And 2 should have been an IBAN. And it's an empty string. Empty string is still a string. Yeah, but my application here, audit system, is reading this IBAN. It's an empty string. It's stupid. It's reading the 2x. It's not an IBAN. Kaboom. Processing, maybe they want to do some thing with amount. -10 makes no sense because maybe it's going to multiply and to create a price. Makes no sense to have a minus price, So all these things, how do you protect again yourself? Today, it's not, again, your CI/CD is not going to save you from this. It's really at the root of the problem is the application producing the data. Basically, you have to have very strict rules in your applications. And again, this is always the same thing. I have a poison pill. I need to be aware. This is what we call the data contract. So, cool, it's an integer, but what are the constraints? Cool, it's a string. What are the constraints? And so on for any of your types. One prototype that we have, this is an Avro schema. So an Avro schema is actually can be defined in JSON, where you just say, this is the shape of your data. At conductor, what we did is, okay, no, we want to add constraints on your field without disrupting, the whole ecosystem. What about just adding these new fields? This new metadata field into your schema directly. So right now, for instance, age, What if you will be able to declare that, okay, it starts at 0, maximum 120. Okay, why not? What if the name, you say, okay, a name should be 3 characters and 50 max, and Kafka should not accept something outside of these boundaries. Why not? All these types, basically, you refine them, you constrain them, like in Postgres, for instance. You can say, I have an array of something. My array should always have like 2 items or 1 items in general. These are the kind of constraints that are going to protect you and protect your producers to not sending something outside of this. Like, who can define this? Maybe not the developers, but like the product owners who own the business. I own my application. I don't own the code because I'm not a developer, I'm a product owner. But I know what my business is about. So I want to protect actually what my team is going to send into my central data exchange, which is Kafka, because I'm responsible for it. My developers, they might not be aware of all the rules. So you should be able to do these kind of things. How do you do this today? Creating a library. Who has a special SDK, like in Java, Python, something, that they distribute to their teams basically to produce or consume data, like a special layer? You as well? Okay, so this is the first thing generally we always do, but the funny story starts with, oh, okay, I'm a Java shop. Today I'm a Java shop, so I will just build an SDK for Java. Java 8, because 8 was cool. No, I mean 17, okay, or I mean 20, okay, but I have to support all Java apps still running on 8. Shit, okay, I have multiple versions. But Rust is very hype, so no, someone in my company build a Rust application. Shit, we need to build a library for Rust as well, to have the same basically rules of my wrapper. Python, TypeScript, and so on and so on. So, okay, we have multiple languages, cool. Oh, no, it's not just a language thing, it's a framework. How do I plug my rules? Okay, in Kafka Stream, Kafka Connect, Flink, Rising Wave, Spark. How do I basically build my UDF for each framework? Okay, it starts to be a bit messy. We are talking at large scale here, not just startup with two applications, but like bigger organization. You are going to have a lot of issues. The team who is going to support basically this, it's going to be a full-time job just to maintain a library, multiple libraries. Not the best. I don't know if you have an SDK, a library?
Yeah, we have a wrapper.
In Java, in Go.
But yeah, I see the pain points. Like, yeah, it mostly helps us to create producer and consumer with good defaults.
Yeah.
We have as well, like, kind of our schema in protobuf, like Avro.
Yeah.
But there is nothing like, minimum, maximum, like,
yeah, this
so we have to do in applications. And connecting with standard tools sometimes is challenging.
Yeah. So this is exactly the kind of thing that you're entering not very fun generally. And let's talk about the proxy, because proxy is a new hypey thing. Proxy, you have to use it when you know what you're doing. This is the first rule. Proxy is not something for fun. It is in the critical path of your application and Kafka, basically. So this is a middleman between in your ecosystem. So this is not to take lightly, but it offers so much power that we are going to discover that it might be super useful to avoid building and having so many issues that we discussed just right now. So everybody knows what is a proxy, and really, you take an HTTP proxy like Nginx, traffic, any ingress, whatever. This is a typical proxy. This is just a middleman with some rules. And this is, in the end, this is your destination. This is your real HTTP server in Python, in Scala, in whatever. And your HTTP proxy is just changing the route, adding authorization, headers, doing something in the middle, just to be sure that you are a bit in control. So this is a very classic pattern. We talk about a Kafka proxy here, okay? So Kafka proxy means we are not talking about HTTP, we are talking about a proxy which speaks Kafka. So 1992, the real Kafka protocol. Conductor, we build this, okay, this proxy thing. It's very easy. This is like Nginx or any HTTP proxy. You hit, we hit Kafka, Kafka hits the proxy, and we hit back the user. It's not that simple in reality. Really not that simple. So why? How does Kafka work? You know, when you connect to Kafka as a producer or consumer, you add a bootstrap server. So the bootstrap server is one of these brokers over there, or load balancer, or whatever. Let's say we have the proxy in the middle, okay? So now you say, okay, I connect to gateway because to my proxy, because proxy is itself connected to the real Kafka. You do this small ping pong, we hit the proxy, hits Kafka. Kafka sends back its answer to the proxy, and the proxy sends back the answer to the application, the client. There is one massive concept that people working with Kafka, you know about that, the advertised listener. So advertised listener is something entirely decorrelated from the bootstrap server, is when you hit any kind of server, they're going to say, okay, how now I'm going to give you an answer to say how any of your producer or consumer should talk to us via which hostname, DNS, IP, you know, something. That is totally different from how do I hit the first one. This concept, these guys, they don't know about proxy. This is like Confluent Cloud, MSK, Red Panda, you know, whatever provider. They are going to reply to the proxy, hey, you hit us by my name. My name is broker 1, broker 2, broker 3, okay, on AWS, on whatever. We are going to send this to the user. And so what's going to happen? This application here, it has been told to say, hey, you have to address Kafka via like broker 1, the hostname broker 1. It's just going to hit the real Kafka. Get the proxy here, gone out of the ecosystem, because Kafka does not work just like this. So what is the answer here? Yeah, no. We have basically to be smart when we get the answer. So we hit Kafka, the proxy hit Kafka. Kafka says, okay, you address me by broker 1, broker 2, broker 3, but we say, no, I don't want my application to talk to Kafka via broker 1, 2, 3. I want them to hit me because I'm the safekeeper, basically. So there is a small funny translation to be made. Say, no, I'm going to change actually what you are sending to the client. I'm going to change the response here, to parse it, to do my magical thing, and to say, no, you speak to me. So this guy now, this application, it will speak to the proxy because right now it doesn't know anymore about broker 1, 2, 3. It just knows about proxy 1, 2, 3. We open a kind of networking stuff to do because now you have to set up basically in your ecosystem where can I find proxy 1, 2, 3, for instance. So a lot of fancy things. I won't go into too much detail on this. But this is how basically we solve. Right now we did the request, response, metadata, and now you can produce data. So this guy, for instance, is producing data here, and this proxy sends data, the real produce, to actually the real broker behind the scene. So it acts as a middleman, totally transparent, totally stateless, obviously. And this is how very high level a Kafka proxy works. Let's go back to everything we saw before, and let's look at just the protocol of the Kafka. So it's public. The protocol is very public. This is a request in Kafka. Or to create a topic, actually, when you call, Kafka admin API or whatever, you are just sending a binary blob with this protocol, and this is how actually the information that are really sent to Kafka itself. And if you look closely, when you create a topic, this is where you have in the protocol itself all the details. What is the name, the number of partition, application vector, blah, 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 all the parameters basically, and a few other parameters. But it means that as a proxy now, I can mess up with all of that. I can do my own rules. I can say, non-partition, nobody, I will deny if anyone try to create a topic with 100 partition. I will say, no. because I'm in the middle right now, I can add any kind of fancy rules to protect you from mistakes. Another one, the one that we all use because it's Kafka, the producer one. So when you produce data, this is actually all the things that your client, your producer is sending to Kafka. The transactional ID, if you do transaction, the famous acts, some timeouts for other reason, and the data that are batch basically, in a batch from the producer to Kafka. It means that you can act on this, you can protect, like, I don't want anyone to send ax 0 in production. I will deny all the produce requests with ax 0. If you just read the protocol and do your thing, you can protect from poor behavior, let's say. It goes on and goes on. And the thing, Kafka today has 74 verbs, HTTP has 9. Okay, get, post, option, blah, blah, blah. Okay. When you multiply, because each request, and for each request and response, it means that you have 150, basically, things to touch in the protocol of Kafka today. And it just keeps evolving with the new evolution of Kafka itself. So it's quite a lot, and this is why Kafka proxy, it's like, okay, this is not a small feat, because you have to basically change all of them somehow. So where do we start? Because right now you understand that as a proxy is a middleman, it reads everything going from application to Kafka. You can do basically anything. You can play on anything. You don't just put a proxy and have fun, and block the whole system. You are an organization, you are in production probably already. You don't want to stop anything to happen. So the first step that we recommend is you put a proxy and you just watch. You monitor what is happening. You monitor the behaviors, who is doing what. You just want, okay, what is the situation of today before doing anything. You can engage into some discussion like, why are you using ax 0, for instance? Because you will detect them, like, just try to understand first. Then you say, okay, now I know what's happening in my system. I'm going to say, I don't deny ax 0, but I will change all the ax 0 to ax all. Because in my business, it's a bad practice, ax 0, there is no reason. I will seamlessly change all the behaviors without asking anyone. Because if I ask someone, they will need basically to update their application, and they will need, to do a rolling upgrade in production. Should I ask them? Maybe not. I can do that for them, and they don't have to change anything. So this is kind of powerful. Then if some guys are still, they don't change anything, even with discussion, okay, I won't block you, but I will slow you down. If you are trying to overcommit, basically you are committing, every record for stupid reason, you have a bug, and you are slowing down my Kafka infrastructure because of that, okay, I'm going to slow you down as well. And if the team, being throttled, has some monitoring capability, they will say, oh, what's happening? I'm being throttled, why? And hopefully it will trigger another discussion. And then in the end, it's been months, you have the proxy, it's been months, you know the state. Now I will say, no, not to you. You don't produce shit. I don't want you to produce bad data in my system because you are breaking many things. I say no. And so right now, the team behind this, the data product, whatever it is, they are not going to be able to publish data to Kafka because it's going to be blocked somehow because they did something bad. So it's going to be the responsibility of this team, and the PO, the dev, the lead, whatever, they are going to have a hard time because they need really to fix what is happening here. And so this is why you don't start just here right now at the beginning, because they are not going to be happy. So it's like a long cycle in the organization. But in the end, this is what you put on everything in Kafka. This way you are fully in control of what is happening with my Kafka. And you will be sure all the question I ask, do you know who is using Mina, yes sir, Axel? Doing this, you will be sure. You will say, yes, I know nobody in my organization is using ax 0, for instance. So this is very powerful, but it takes time. Let's start to go into a bit more use case. Just 3 small slides. I was talking about idempotency earlier. Right now, with a middleman, you can test your application if they are idempotent or not, because the middleman can duplicate records without creating them really in Kafka, but it can simulate that, hey, I have 10 times the same records. Are my applications going to respond well? Did they implement some kind of idempotency, check? You will know. Poison pills, very easy with a middleman. It's very easy to send junk, not in Kafka, but to simulate that you are sending junk. This way you will see if the applications are actually failing, or if nothing happened and they are dealing properly with poison pills. The last one, the tricky one, to add latency. When we build Kafka, we build application, we all think that the network, it's very speedy, it's like milliseconds. What happens is if you add 1 second of delay in all the Kafka requests, everything. Is this going to fail everyone or not? This is the kind of thing you can do like with a click, because you are again in the middle. And now we are going to dream a bit more. Some of them. Encryption, massive use case. You are in the middle. I'm a bank, I'm an insurance, I'm whatever. I want to encrypt my data at rest. So my provider, I love them, but I want to encrypt my data because of regulations. I have to send my data out to them already encrypted. Today, if you don't have a proxy, you have a Java SDK, you have something on your client side to encrypt the data. But to encrypt the data, you need them to be connected to a KMS, to your AWS KMS, to some form of key cryptography. Do you really want to give all your KMS keys to your applications? Probably not. The PDF thing, the PDF is a funny one. You can say, okay, you really want to send 70 megabytes in Kafka. I'm not going to write 70 megabytes in Kafka because I know it's stupid, but I'm going to write them in S3. And I'm going to just, in Kafka, to send just a reference to the bucket, to the record. This way, Kafka never saw 70 megabytes, but just S3. And you do this when you consume data, you fetch the data back seamlessly from S3. So it's not just storage, it's something in the middle. This one is my favorite, caching at the edge. I have Kafka in the US, I have Kafka in Europe. My application in Europe, they need my data from the US. So all of them are fetching the data from my cluster in the US. They probably read the same, multiple applications are probably reading the same topic from the US. So every single application is eating basically the networking cost and the networking latency to go fetch the data from the US and to bring it back to Europe. You add a proxy in Europe. And every single time there is someone fetching the data from the US, you cache it in Europe. And the next application reading the same data is going to hit the proxy in Europe, say, oh, I already have this data. Because Kafka is immutable, so you can cache the data. You are not going to pay a round trip to the US. It's going to be just as if it was in Europe. So this one is very cool. Last one, multi-tenancy. So it's something that does not exist in Kafka yet. It will probably come. It exists in Pulsar, for instance. But it's how do I create my own virtual Kafka in an existing physical Kafka. Today, you need basically to have like prefixes for your topics, your consumer group, all your schemas, and so on and so on. What if I tell you that you can create a new fresh world from scratch in just one API call that is totally empty? Because it's like a virtual machine, it's like VMware, it's like all this kind of technology. You just create a pure new world in your Kafka. Meaning that you can, we had this in production a year ago, we had like 5,000 virtual clusters on one physical Kafka clusters. So it helps basically to scale your demand on one physical cluster to really make sure that you are using your resources of your Kafka clusters like fully.
Can I just add that
Yeah.
last use case is so common. You see it everywhere. Everyone prefixes their environment to share a cluster, and it's to save cost.
Yeah, and it's the same, yeah.
And to do that.
But you need ACLs and all the things that comes around the naming. So it's doable, but yeah, it's tricky. And the last one, so level over 9,000. Data quality, we talk about it. I'm a proxy. I can enforce that if you are sending data to my topic finance, I can enforce that no one is going to write to this topic if it is not following a very specific shape, format of the data, and so on and so on. You can do that very, very easily. The data of production in staging for free, like a lot of us, I think a lot of you want to have your prod data in staging. This way you can simulate, some use case. You have to to replicate your data probably today. With a middleman, you can basically say, okay, I'm a middleman in staging, but I want to open an access to my production environment, very controlled on this topic in read-only, and you don't need basically to duplicate the data. And so your staging application will hit your staging, proxy that will actually hit the production cluster. You can add a layer of caching, for instance, to not hit too much your production, and basically you just have access to your prod very securely without doing any fancy things in like a few minutes. So this is, I won't enumerate the rest. I think it's we have enough probably. But yeah, basically a middleman can enable a lot of things. Oh shit, the last one. Do we have an architect in the room? Okay, no architect, so no question, because an architect will say it's a single point of failure, obviously. I will just say, no, it's not. Done. So yeah, anyway, this is the end. Link to the presentation if you want to revisit it. Thank you very much.